In this video, I wanted to talk about how we can use Python in order to create a password hash. Now, if you're not super familiar with the idea of a password hash, what happens is when you create a password on most computer systems, it doesn't actually keep your password. What it does is it puts it through a special mathematical process that only works one way in order to create what's known as a hash, and then that hash is what's kept in order to help identify your password in the future. So I'm going to show how that works under Linux and how we can use that in Python. So we'll start off here on my Raspberry Pi machine. And I'm going to start just by creating a couple of users. Very simply, I'm just going to create a couple of users using sudo user add and test user 1. And then I'm going to do the same thing, up arrow, and create a test user 2, just so I can have 2 users to play with. Now, when I create the users on the Raspberry Pi this way, it doesn't create a password for them, so I have to then do a sudo password, passwd, test user 1, and it prompts me for the password. I'm going to give it a really simple password here of QWERTY, just QWERTY, QWERTY. Enter. Confirms QWERTY and enter. Using the up arrow key on my keyboard, I'm going to then do the same thing for test user 2. Same password, QWERTY, enter QWERTY. Now just to confirm so everybody can see, that is the password I am typing in for this user, for both of these users. Okay, so to confirm the fact that I am not actually keeping passwords, but I'm keeping password hashes, I'm going to review what these passwords are, and they are stored in a file on the computer. So I can do a sudo cat in order to spit out the contents of it, and that file is etc shadow. So sudo cat /etc/shadow, and this will spit out the password file for all of the users. And here I can see the last 2 users, test user 1 and test user 2. And the next chunk right here is the password hash. Now, I gave both of these users the same password, yet as we can see, the hash is different for both of them. So for this, we can actually start finding out how Python creates password hashes, or more specifically, how computers create password hashes, and then how we can do that in Python. So I'm going to give a very brief description here of the password hash that we're seeing here. Basically, it is 3 different chunks. We start off with the first chunk, the $6, which tells us what type of a hash it is. In this case, $6, I believe, stands for a SHA-256 hash. There is a $1, a $2, $3, and so on. The next portion of the hash here between the 2 $signs is what's known as the salt. Now, the salt is some additional text that's added to the password to help make it unique every single time it's stored. This salt is actually the reason why our 2 hashes for test user 1 and 2 are different, is because the salts are randomly added to each one, resulting in a different hash for each one. And then lastly, we end up with the actual password hash right here, which is, again, different for each user. So let's see how we can create this in Python. So I'm going to do this in the Python interactive mode. So I'm just going to type Python 3 to go into interactive mode. And in order to make this work, I need to import a library, specifically the crypt library. So import crypt will then import that password or that library into my local environment. Next thing I want to do, well, let's go ahead and print, parentheses, crypt.crypt, parentheses, and the password I want to encrypt, which in this case is QWERTY. And then 2 closing parentheses. I always have to make sure that the parentheses that are opened are then closed, right? And then I hit enter, and I see a password hash there. Same kind of breakdown there that we saw previously. I have the hashing type, I see the salt, and then I see the hash itself. Now, if I up arrow and hit enter, I can see the same thing again, except with a different salt and therefore a different hash over and over again. Okay, so creating a password hash is just that simple. And we can actually get this a little bit more interesting. Here I have the same thing in a Python script. We're starting off here, basically, importing the crypt library. We then prompt the user using the input statement to ask for what password we want to encrypt. And then lastly, here in lines 13 through 17, we are producing different hashes, all based on different encryption types, which we can see by here the $6 being for the SHA-512, $5 for the SHA-256, and so on. If I go ahead and run this, we'll see that it will prompt me for a password that I want to type in. And to be simple, I'll stay with QWERTY. And then I hit enter, and it spits out the various encryption types that we might see. And we can see, for instance, here's the MD5. Blowfish and EKS Blowfish apparently aren't supported on this computer. SHA-256, and then SHA-512. Now, as you can guess, just by simply looking at the length of those hashes, the SHA-512 is probably more secure than the other types. Not always, but possibly. All right, so we've gone ahead and we've created our hashes, but we're still in a situation where every single time we create a hash, it's completely different, even though the password is the same. Well, we actually are missing one small item here when we do our crypt. And in fact, what we're doing is we're only giving it the password that we want to encrypt. We're not telling it the type of hash we want, nor the salt that we want to go with that. If we pass both the type of password and the salt, which is this portion right here before the third $, then we can be sure to get the same password or the same hash when using the same password. So if I up arrow and I edit into this, and what I'm going to do is I'm going to copy this highlighted text right here and paste it in between these quotes. What we're doing this time is now we're saying go ahead and encrypt this string, this password, using this salt. And now when I hit enter, what will happen is we'll see that our last two hashes right here are exactly the same. All because we use the same salt and the same encryption mechanism. And that's actually how passwords are encrypted and then confirmed when you log in. The hash is stored in the etc shadow file, and then when you log in, the salt is taken out of that file, used to encrypt your password, and then confirmed against the file again to make sure that the hash is the same. Well, let's confirm this. If we come back here into our Visual Studio Code, I actually have another hashing script here. And in this case, we prompt not just for the password, but we also prompt for the salt. Once we're done with that, we work exactly the same as what we did before. We use the crypt.crypt method. We pass it the password. We pass it the hashing type, in this case, $1, 2, 2A, 5, and 6. And we add the salt to it. So let's go ahead and try this script. So I'm going to go ahead and run this. And actually, before I do this, let's get back to my prompt here. Let's exit out of interactive mode. And I'm going to look back at my shadow file. And the reason why I'm doing this is because I want to find the test user 2 salt here. I know that I used the password of QWERTY. And so now I want to actually see if I can recreate test user 2's hash file here. So here I am. It's asking me for the password. The password should be Cordy. It's then asking me for the salt. And just to confirm, yes, salt doesn't need to include the $sign. Come back here and I copy everything between the $signs. Copy. And then I paste it in here. So now I have both the password and the salt, and I hit enter. And so now it then spits out the hashes. And lastly, I can go ahead and confirm if this is the same hash as what was in the shadow file. And yes, it looks like it was. So that's how we can create password hashes to be able to safely store passwords without actually storing the passwords, and then validating that the passwords have been matched or haven't been matched properly.